Hello, boys and girls, and welcome back to math class. I'm your host, Mr. Eichler. Today, we are going to talk about symmetry. What is symmetry, you may ask? Well, I'm here to tell you. So, symmetry is a figure that can be folded flat along a line so that the two halves match perfectly. That is a symmetrical figure. Okay, so what am I talking about? Make myself a little bigger here. So we got a piece of paper, right? And this is just a normal, everyday, rectangular piece of paper thing, okay? If I take this piece of paper and I line up the corners so that each corner is perfect, and then I fold it this way, okay? If I unfold this rectangle, I now have two rectangles the same size. This is symmetry. The line down the middle, the fold on the paper, that is your line of symmetry. Okay, now, I can also take my piece of paper and I can fold it this way, corner to corner. And you will notice something isn't quite right about my shape. I got pieces hanging over the edges here, okay? This is not symmetrical. They do not line up perfectly. I'm trying to center up here. They do not line up perfectly. They do not make a symmetrical shape. Does that make sense? So the line itself is called that line of symmetry. Okay, lines of symmetry. So how do we cut shapes up? Well, circles are pretty darn easy to do, actually. So long as the line passes through the center of the circle, there will always be symmetry. So I can draw the line any which direction, and it's going to make a symmetrical half circle, so long as it passes through the middle point. The same could be said for a square. I can draw a line of symmetry from either the corners or from the middle of the square. And again, so long as it goes through the center, you have a line of symmetry. However, if I don't go exactly on the middle or exactly on the corner, this is not symmetrical. Neither is that, neither is that, neither is that, okay? Rectangles, lines from the middle of the figure, not along the vertex. So if I go this way, as I just showed you with my piece of paper, that will be symmetrical. Likewise, if I go this way, this half and this half, perfectly symmetrical. However, if I go corner to corner, just like I showed you before, that's not symmetrical. That's what it looks like. And you have pieces hanging over the side of the shape. So yeah, that's not going to work very well. Triangles, from the middle of a vertex where the sides are even in length. So if I go from here to here, or here to here, or here to here, these will be perfectly cut half of this equilateral triangle. However, if I have an isosceles triangle, I can only come down from the top vertex to the bottom. I can't go that way and that way. Because as you can see, this will be one half, this will be the whole other half, and that's not the same half. Make sense? Same thing can be said for a right triangle. Again, if I start here at the vertex of the right corner, the middle, and I go to the edge, that will be symmetrical. However, from both sides or from the other two corners will not be lines of symmetry. These are asymmetrical shapes. These figures are not symmetrical, and it doesn't matter how I cut them up. They are never going to give me a symmetrical shape. Okay? That's all I got, guys and girls. You have an activity in your OneNote, so if you would please complete that for me, and that's all I got. Everybody have a great day.